Java's interface is a useful language mechanism for expressing an abstract data type. An interface in Java is just a list of method signatures, no method bodies. And then a class implements an interface if it declares the interface in its implements clause at the top of the class declaration and provides the method bodies that we're missing for all of the interface's methods. So one way to think about an abstract data type in Java is that it's an interface, because it's defined entirely by its operations, and then its implementation is a class that implements that interface. Now, one big advantage of this approach is that the interface specifies the contract for the client and nothing more. The interface is all that a client programmer needs to read to understand the ADT. The client can't create inadvertent dependencies on the ADT's rep, because instance variables can't be put in an interface at all. You don't have a rep. The implementation is kept well and truly separated in a different class altogether. Another advantage is that multiple different representations of the abstract data type can coexist in the same program as different classes implementing the same interface. When an abstract data type is represented just as a single class without an interface, it's harder to have multiple representations. So in the MyString example from the earlier reading, MyString was just a single class. We explored two different representations for MyString, but we couldn't use both representations for the ADT in the same program. Java static type checking allows the compiler to catch many mistakes in implementing an ADT's contract. For instance, it's a compile time error to omit one of the required methods, or to give a method the wrong return type. Unfortunately, the compiler doesn't check for us that the code adheres to the specs of those methods that are written in the documentation comments.